Hi, this is going to be a quick video on how to simplify radicals. Hi, this is going to be a quick video on simplifying radicals. So before we get started with this, I do recommend that you always use a list of perfect squares and cubes when simplifying radicals. This is a list I provide my students with your perfect squares, your perfect square roots, as well as your perfect cubes and perfect cube roots, the parts of a radical, and the parts of a power. This will be linked in the YouTube video as well in case you need this. So with this handy and by our side, we're going to get started with some basic questions. So we're used to doing problems like this. Simplify the square root of 144. Well, we know that the square root of 144 is 12 because 12 squared is 144, or the square root of 144 is 12. Now there's a couple different answers here. Really, there's a positive 12 as an answer or a negative 12, because 12 times 12 would give us 144, as well as negative 12 times negative 12 would give us 144. So sometimes if you see this is saying give me the negative answer, and so you know it's asking for the negative answer. Usually we just assume it's giving the positive answer, and usually it'll give you instructions. It'll say list all solutions to this expression, or this problem. So let's dive in with how to do these. So these are really easy. We've done these in 6th grade, 7th grade, 8th grade. What happens when we start moving into ones that are not on this list, okay? So for example, what if I gave you the square root of 45? As you know, 45 is not on this list of perfect squares. 49 is, but 45 isn't. So how do we simplify this? You can put in the calculator, and we know it's going to be an irrational number. It's going to be a decimal that goes on forever with no pattern. It does not repeat. But that's not what we want to do. We want to simplify this on our own. So the easiest way to do this is to always use this list. So what I tell students to do is go to this list and find all the numbers smaller than 45 on this list. So that would be 36, 25, 16, 9, 4, and 1. And basically you're going to go through this list and you're going to look at these numbers and you're going to say, okay, well, does 36 divide evenly into 45? No. Does 25 divide evenly into 45? No. Does 16 divide evenly into 45? No. Does 9 divide evenly into 45? Yes, it does. So what we're going to do is we're going to use this rule, and the rule basically says that the product of the square root of a times b is equal to the square root of a times the square root of b. So we're going to break this down, and we're going to use that square root of 9, because we know that 9 divides evenly into 45. So I have the square root of 9 times what number gives us 45? Well, that number is 5. So this breaks into the square root of 9 times the square root of 5. We are always going to write the square root symbols because we're not doing 9 times 5. We're doing the square root of 9 times the square root of 5. So when I do this, the square root of 9 we know is 3. So we know the square root of 9 is 3. So we're going to simplify that. The square root of 5 is not on my list, and 5 is a prime number. It cannot break down any further. So we're just going to bring that down as is, and my solution is going to be 3 on the square root of 5. So the simplified version of the square root of 45 is 3 on the square root of 5. And that is what our answer is going to be. Yes, we can also put in the calculator. However, we're going to solve these and simplify these on our own. All right, another example, what we're going to do is going to be the square root of 72. 72. Okay, 72 is not on my list, okay? And you can use a calculator for this part if you need to find the factors. So we're going to test everything smaller than 72. Does 64, which is 64 down, does 64 divide into 72? No. Does 49 divide evenly into 72? No. Does 49 divide evenly into 72? No. Does 36 divide evenly into 72? Yes, it does. So we can break this up into the square root of 36 times the square root of 2, because 2 times 36 is 72. So when I simplify this, I know the square root of 36 is 6. The square root of 2 is a prime number, so we're going to bring that down. I'm going to get 6 on the square root of 2 as my solution. Now, I know that 36 divides into 72 because I've been doing this a long time and I'm very familiar with these numbers. If you are somebody who is new to this and you said, well, I'm not sure if any of these other numbers do, but I know that 9 divides into 72. I want to show you what would happen if you'd use 9. It means a little bit more work. It's not wrong, it's just it's going to mean more work. So when I do this, I get the square root of 9 times the square root of 8. We know the square root of 9 is 3. That is simple. The square root of 8, however, is not prime like 2 was, so I cannot be done here. I have to check and see, is there a perfect square that divides into 8? Well, there's only 2 numbers smaller than 8 on my list. That's 4 and that's 1. And yes, 4 does divide into 8. So I can simplify the square root of 8 into the square root of 4 times the square root of 2. Well, I know the square root of 4 is 2. And so this becomes 3 times 2, because I bring down that 3. 3 times 2 times the square root of 2, which still gives me 6 on the square root of 2. So you're going to get the same answer either way. The issue is, which way do you want to do the most work? I don't want to have to do this. The more work is the more chances for opportunities for mistakes. If I can find the biggest perfect square that divides into these, I can be done much, much faster. So that's how we do these. I'm going to do one more a little bit challenging with multiplication. So, I don't know why I just said number 10. This would be number, this would be number 5, or 4, because that was number 1, that was number 2, that was number 3, and this is number 4. I don't know what I am doing. That's part of life. We make mistakes, though. So, what if I gave you 10 on the square root of 96 for number 4? 10 on the square root of 96. Okay, so this 10 is being multiplied by this radical. So I'm going to keep that 10 out here hanging out. That 10 is going to just come, hang out, chill. And we're going to come back to our list. We're going to say, okay, 96 is not on my list at all. But what number smaller than 96 divides into 96? Well, we can start with 81. Does 81 divide into 96? No. Does 64 divide evenly into 96? No. Does 49 divide evenly into 96? Close, but no. Does 36 divide evenly into 96? Now that one, even with me, I'm going to check that one. I'm going to just make sure, because that one looks like it might work. And that's the thing. If you think it might, check. It does not work. We know 25 doesn't divide into 96, but does 16 divide into 96? It does, in fact. So we can simplify this into the square root of 16 times the square root of 6. So we know the square root of 16 is 4. There's also this 10 out front, so I have 10 times 4 times the square root of 6. 6 is not a prime number, but the only factors of 6 are 1, 2, and 3. None of those other than 1 are a perfect square, so we're not going to simplify this any further. We do know 4 times 10 is 40, so I'm going to end up with 40 on the square root of 6 as my solution here. So that is how we do these ones with the multiplying out front. I'll do one more challenging one with multiplying, and then I'm going to show you 2 or 3 quick division problems. So if I'm looking at one with a variable in it, so this is actually question number 5, because I can actually number them now. What if I gave you 125 n cubed? Okay, so 125 n cubed, my suggestion is always split these guys up. So I'll split into the square root of 125 and the square root of n cubed. Okay, so the square root of 125 is not on my perfect squares list, so everything 121 and smaller is going to be a possible factor. This ends in a 5, so I'm going to probably guess that 25 is the largest perfect square that goes into 125, and I'm going to guess right. So I'm going to break this into the square root of 25 times the square root of 6, or not 6, of 5. Sorry about that, square root of 5. I know the square root of 25 is 5, and the square root of 5 is prime, so that's going to be my numerical portion. What about the variable? So n to the third. I'm going to show you a shortcut, and I'm going to show you the long way in the shortcut. What I can do is I can break this into n squared times the square root of n. Well, the square root of anything squared, and we've talked about this, will cancel. The square root of anything squared will cancel and just leave me the radicand, which is n. The square root of n cannot cancel, so that stays under the radical. So now I have times n on the square root of n. So when I do this, I'm going to bring the factors out front, the coefficients out front. I have 5n on the square root of 5n would be my solution here. The shortcut to this is we know that a radical is the same thing as saying something is to the 1/2 power. So I could rewrite this if I wanted to as n to the third raised to the 1/2. And that would say 2 divides into 3 one time. So there's 1n outside the radical. And then it has a remainder of 1. So there's 1n left under the radical. So that's just a little shortcut to think about if you need it. And we'll practice that more. But that is there as a shortcut to use. Now, the last thing I'm going to show you is what do I do if there's fractions involved. Okay, so this is actually example number 6. And example number 6, we're going to start with the square root of 4, or let's do square root of 9 divided by 49. Okay, so just like we used this rule for multiplying, we can use this rule that the square root of a divided by b is equal to the square root of a divided by the square root of b to solve this. So we can split this up to the square root of 9 divided by the square root of 49. Those are pretty easy. They're on my list. They're right here and they're right here. So I get 3/7. What if it's not that simple though? What if in example 7, I give you the square root of 4/5? So I'm going to split this up. Easy peasy. Square root of 4 we know is 2. The square root of 5 is a prime number. Here's the issue. We can never leave a radical in the denominator. So we call this rationalizing the denominator. So what I'm going to do is I'm going to multiply the denominator by the square root of 5 and the numerator by the square root of 5. And here's what happens. When I do this, I'm going to get 2 times the square root of 5 in my numerator. In the denominator, as long as they always multiply by the same thing, the radicals will cancel each other out. Okay? The square root of 5 times the square root of 5 is going to give me just 5. Okay? Because essentially what this is, if you want to do a little thought bubble here, this is the square root of 5 squared. And we just said the square root of anything squared, or squaring any square root, will cancel and leave me just the radicand. So once I've done that, that is all I can do. I no longer have a radical sign in the denominator. I'm good to go. I'll do one more example with you, and this will be example 8. And I think I actually did those the right way this time with the numbering. Good. All right, so example 8, I'm going to do the square root of 1/12. So I'm going to split these up to the square root of 1 and the square root of 12. The square root of 1 is pretty easy. That's just 1. Square root of 12 is tricky, okay? This one, the square root of 5, was not on my list. It's a prime number. I know that I just had to rationalize that denominator. The square root of 12 can be broken down. In fact, we can break square root of 12 down into the square root of 4 times the square root of 3. So the square root of 4 is going to be 2. We know that. And the square root of 3 is prime, so it's going to stay the square root of 3. So what I have right now is I have 1 divided by 2 on the square root of 3. So the 2 is fine down there. The 3 is not. The 3 is not okay. We need the 3 to go away because it's a radical. We can have just the 3, but we can't have the radical. So to rationalize the denominator, I'm going to multiply the denominator by the square root of 3 and the numerator by the square root of 3. So my final answer is going to be the square root of 3 divided by 2 times the square root of 3 times the square root of 3 will cancel and just become 3. So it's going to become the square root of 3 divided by 6. And no, I cannot simplify to that to 1/2 because this is under the radical, this is not. So, couple of things, use your square root and perfect squares sheet. That's going to help you a ton. Always check for the largest perfect square. Always rationalize your denominator. Make sure there's no radicals in there. And just practice. The better you'll be at this is directly related to how much you practice this. The more you do it, the more you'll start seeing, oh, I know what number goes into that. I know what perfect square goes into that. I know this can break down further. All right, I hope this video helps, and if you need anything else, let me know.